there's a big problem there, because it would be extremely inconvenient for a multi-billion-pound operation such as CERN, if somebody did come up with the answer that they're trying to find in terms of how everything works. It'd close it down, because there's no longer any need to find out how everything works when you know everything works. So, and they're looking in the wrong place. They're looking at higher and higher energies. And the good thing about higher and higher energies is they cost a lot of money, and it's all esoteric. And they have a big salary structure there. They have nearly £1 million salaries at the top. So closing down would affect their pensions, right? Apart from their... So there's an enormous resistance to simple theories of how stuff works like this in the community. There's a vested interest in keeping up the search for higher and higher energies to find the meaning of how everything works. But I think they're looking in the wrong place. I think they need to look at how the electron, proton and neutron, how low energy things work, which is what I'm doing. And you need to understand how the zoo of particles comes about. What I mean by the zoo of particles, there are literally hundreds of elementary particles now, so-called elementary particles. That's not quite true. There are models which have sub-elementary particles. So, for example, the proton is not considered entirely elementary. It's considered to be made of quarks. And if you look at those, there are, what are there? There are 6 quarks. There are 8 gluons. There are a set of things that interact with the quarks. There are 6 leptons. There are a whole set of these so-called elementary particles, which then are supposed to make everything up. Loads and loads of parameters. They're governed by, quantum chromodynamics has about 50 free parameters. They're governed by things that can pretty much fit anything. And these are non-perturbative theories. Quantum chromodynamics, that standard models' view of how hadrons work, how protons and neutrons work, is a non-perturbative theory. Now, non-perturbative sounds like James Bond. I'm not perturbed by anything, right? But what it means is it means that you can't calculate anything with them. Non-perturbative means that a perturbative theory is one that you can't handle by normal analytic means, but you can use perturbation theory to look at something you can solve and then perturb it a little bit and then solve it. An example of that's quantum electrodynamics, which you can calculate to 10 decimal places with and get the right answer, always. But the other theories, quantum chromodynamics, are non-perturbative. It means that if you try and do things a bit better, the answer just changes exponentially, just goes off somewhere. So they're not useful theories. You can't calculate anything with them. And if you can't calculate stuff, you don't know what you predict. And if you don't know what you predict, you can't test it. If you can't test it, you can't hit it with the scientific method because you don't know what you're expecting anyway. So they're indestructible because they're useless. So, and that's why I left hydrogen physics, because I saw that that was the case, and that was a waste of time. But of course, there's a lot of resistance to anything which will perturb that cosy life. Anyway, this is stuff that probably shouldn't go out in public, so it should get me into even more trouble.